Welcome back to the sequence of videos where we are talking about L'Hopital's rule and indeterminate forms. In the previous video, where we just introducing you to the L'Hopital's rule, I actually never mentioned that the cases 0 over 0 and infinity over infinity is one of the indeterminate form cases. So we told you can use L'Hopital rule when you see a ratio like that. And those are the cases called indeterminate because they're not obvious. It's not like actually we're dividing 0 by 0. It's a function in the numerator that goes to 0 and the function in the denominator that goes to 0. And like I told you before, our job is to learn which one is faster, right? And if 0 wins at the top, it's one story, everything is 0. If 0 wins at the bottom, it's different story. Division by 0 gives you some kind of infinity, and so on and so on. Well, we have more forms, 7 in total, and usually the first two goes in couples because we just apply L'Hopital's rule right away. And then in this video, I will try to show examples for the other two and then finish these three last forms in a different video, or else it will be just too long to watch, I think. So let's see what is happening when you're working with the limit and instead of the ratio, you actually see a product. Well, the idea here is to convert this product into the quotient. Is it possible though? Yes, it is. Idea is, for example, tell me if I'm working with 5 times 8, but I don't like that and I want to have a ratio. Is it possible to create a ratio from the product 5 times 8, which is 40? Well, I can do 5 over 1 over 8. Is it the same thing? Yes, it is. Because by dividing, when you divide by a fraction, you actually multiply by the reciprocal, so it is 5 times 8, which is 40. Also, I can rewrite it in a different way. I can put 8 in the numerator, and then what goes to the denominator? 1 over 5. Then, since I'm dividing by a fraction, I have to multiply by the reciprocal, so it becomes 8 times 5 again. And all of those cases give you 40. It doesn't matter. So that's a legal way to convert the product over here into L'Hopital's rule, which basically converting the product into quotient. I'll go it over here. Topic is called 0 times infinity indeterminate form. 0 times infinity form. So just a note to have nice explanation for the future. Note or idea is when you're working with 0 times infinity, I will write down right below 5 and 8, 0 times infinity, I can write down this product as 1 over infinity, or infinity over 1 over 0. And it's the same thing, just like I explained you with 1/8 and 1/5 over there. Again, remember, we're not actually dividing, we're not actually multiplying 0 by infinity. There's a function f that goes to 0, and there is a function g that goes to infinity, and we don't know which one is going to win. Because 0 times everything, intuition tells you should be 0, but infinity times everything, intuition tells you it should be infinity. So it actually depends which one is faster. If f is faster, decaying to 0, then everything will decay to 0. If g is faster, growing to infinity, then everything will be infinity. Imagine if we are talking about a black hole which shrinks everything to nothing, to 0, and there's an explosion inside of the black hole, so it stretches everything to infinity. Which process will be faster? If explosion is faster, everything will blow up to infinity. If black hole is stronger, then it will just bring everything to 0. That's one of the examples I was reading in the space science book. So let's do this. Just have this as a nice memo. over here. And the official definition in green will be if you're working with a limit f of x times g of x, and x, as x goes to a or infinity, and you have 0 times infinity or infinity times 0 case, then this will be the same as if you rewrite this limit as a quotient. You'll have f of x at the top and 1 over g of x at the bottom. What case this is going to be? This case, let's see, f of x, so we say agreed that f of x is the one that shrinks to 0, and g of x is the one that goes to infinity. We just agree on this, so say, just a choice, it doesn't really matter. Then, in this case, f of x still grows to 0, g of x still goes to infinity, but 1 over g of x now grows to 0, right? Because if denominator explodes to infinity, 1 over infinity is 0. So now this is a 0 over 0 case. Or you can change the order and keep g of x at the top as x approaches a, and then 1 over f of x will be at the bottom. In this case, g of x goes to infinity. That's because we agreed on that at the beginning. F of x goes to 0, but 1 over f of x now goes to infinity. And this is infinity over infinity case. Why it's good? Because now for both cases you can use L'Hopital's rule and finish it. L'Hopital's rule means you will differentiate the top and the bottom separately as many times as needed to get the result. So finish the memo. The idea is 1 over infinity over here goes to 0, so it's 0 over 0 case. 1 over 0 over here is infinity, so it's infinity over infinity case, and that means now you can use L'Hopital's rule. Make sense? Make sense or not? I think it's easier to explain if you work with example 1. And this is a classical example with x approaches 0 from the right, and x is multiplied by natural log of x. You see this example in many places because it's just very convenient to explain this idea using this example. So x at 0 is 0, but natural log, which can approach 0 only from the right, is negative infinity. Do you remember that? I will show you the graph just in case you forgot. Log looks like this. So when x approaches 0 from the right, not from the left, from the right, then natural log goes to minus infinity, right? Minus infinity over here. So this is the case which we can call 0 times minus infinity. Minus or plus doesn't really make a difference. And we're going to follow the suggestion to create a quotient from the product in order to use L'Hopital's rule. Now it's up to you to choose. Do you want to have a quotient with x at the top or log at the top? You will see the answer will be the same. Standard recommendation is to put natural log at the top, because if you put natural log at the bottom, it will be 1 over natural log. When you will be differentiating that, it will require chain rule, maybe even several times, and it's just usually not convenient. So recommendation is put log at the top, don't touch it. Then at the bottom will be not x, but 1 over x. Make sense? That's the whole idea, is to change one of the factors into a fraction or into a ratio. Let's check that we fixed the situation, or basically made it better. Log, as x approaches 0 from plus, still goes to minus infinity. X, as x approaches 0, still goes to 0, but 1 over x now goes to some kind of infinity, plus or minus. Well, from the right, if you remember, it looks like this, 1 over x. When x approaches 0 from the right, it's actually plus infinity. I would say it doesn't really change the answer at this moment, but at the end might be important. But in order to use L'Hopital's rule, we don't really care about the sign. Let's keep it though. So it's infinity minus over infinity case, and I'll put a notation that I'm using L'Hopital's rule here. And L'Hopital rule tells me that now, if both functions are differentiable, I can find derivative of each. I'm not going to do quotient rule. I'll find derivative of each function and then compare the ratio of derivatives instead of the original functions. ln x gives me 1 over x. 1 over x, do you remember the shortcut for the derivative of this function? Negative 1 over x squared. Do it slowly if you need. Now, don't plug 0 yet, simplify. Looks a little bit weird, but I will recommend you to see it in several ways. Either you need to see that you're dividing by fraction, so you will take the fraction in the numerator and multiply by the reciprocal, right? This is one of the ways to see it. I'm multiplying everything by negative x squared over 1, and then cancel out x's. The other way to see it is to multiply everything by the x squared. If I multiply everything by x squared, I will do like this little note. For people who are struggling with fractions, I know that there are some people who are watching these videos who struggle with fractions. If I multiply top and the bottom by x squared, or negative x squared if you want, I will have negative x squared over x and negative 1, actually positive 1, because I'm multiplying by negative x squared. So the answer is negative x squared over x, right? So 2 ways to see the situation. In both cases, when you simplify, you will have limit as x approaches 0 from the right, and then I will have negative x squared over x gives me just x. Well, in this case, x approaches 0, the answer is 0. So who won? Who do you think was faster going to 0? Linear function x or log going to minus infinity? Well, seems like x won. X was shrinking to 0 faster than log was going to minus infinity. So the answer is 0. Example 2. The second example is a little bit longer and involves some trigonometric functions. Limit as x approaches 0 from the right, 5 sine x times natural log of x, that's it, equals. Well, same idea. Let's see. What's happening with sine at 0? It is 0. What's happening with log at 0 from the right? It's minus infinity. So this is the case 0 times minus infinity. The extra question, what happens with 5 when x goes to 0? Nothing happens with 5. It doesn't go anywhere. It's a constant, so it's just 5. Then, if it's 0 times minus infinity case, we have a recommendation now to switch from the product to a quotient in order to use L'Hopital rule. Well, which function do you want to keep at the top and at the bottom? The recommendation I gave you is, dude, just keep log at the top. Then 5 sine x will go to the bottom in the form of 1 over 5 sine x. I don't like having this 5 in denominator. It'll make it look more confusing. So we're just gonna kick it out using properties of limits. 5 goes outside. Then at the denominator, I will have 1 over sine x. One more recommendation. Please don't do slash in the denominator. I saw many students making many mistakes when they differentiate after this step. So I do not recommend you to use slash. When I actually write down the complete fraction, 1 over sine x, Somehow the brain likes this way better, and when you differentiate it, it does less mistakes. Trust me on this and try not to use slash in your notation. Let's check that we fixed the situation and now we can use L'Hopital's rule. Log as x approaches 0 plus is minus infinity over sine at 0 is 0, but 1 over 0 gives you some kind of infinity, and actually it is plus infinity. So infinity over infinity case allows me to use L'Hopital's rule if both functions are differentiable. 5 outside, don't forget. Still a limit. X approaches 0 plus. The derivative of the top is 1 over x because it's log. The derivative of the bottom is negative 1 over sine square x, right? That's how we did before with 1 over x. Then chain rule tells me times derivative of sine, which is cosine x. Do it slowly if you still struggle with taking those derivatives. But remember, soon we will be expecting from you to be very fast in taking derivatives of all kinds of functions. Okay, now we just need to calculate what is this. And this limit seems to be not very obvious from the way it looks right now. So let's rewrite it and hope it will become better after rewriting it. It's going to be 5 limit as x approaches 0 plus. Let's multiply everything by the negative sine x squared. So it's going to be negative sine, not x squared, negative sine squared x, that's not the same thing, negative sine squared x all over x, because x was in the denominator, and cosine x, because cosine should be in the denominator as well. Either you see it as a reciprocal of this fraction over here, right? Or multiply everything by negative sine squared x. So this is what I'm having here. Let's see, maybe now I will have the answer. I'm planning 0, and at the top I will have 0, because sine of 0 is 0, and squared gives me still 0. And at the bottom I will have 0 times 1, because cosine of 0 is 1. So I have 0 over 0 case. How to proceed? 2 ways to do it. Way 1. The first way is to apply L'Hopital's rule one more time, right? If it's 0 over 0 case, then I will say, hey, let's differentiate the top and the bottom one more time. The top function gives me chain rule, and I kind of don't like this negative sign over here. Let me kick it out outside of the limit. So negative 5 now is outside. Limit x approaches 0 plus. Now, sine squared becomes 2 sine x to the first power times derivative of the function inside, which is cosine x, and that is all for the top. The bottom part is product rule. Derivative of x is 1. Copy cosine x. Plus copy x. Differentiate cosine. That gives me minus sine x. A little bit long, but I think we're almost done. Let's check. When I plug 0 at the top, cosine of 0 is 1, but sine of 0 is 0. So I have 0 at the top. When I plug 0 at the bottom, this whole piece is 0, because sine of 0 is 0, and x at 0 is 0. But this whole thing likely is not 0, or else we will have to struggle more. Cosine of 0 is 1, so after all, I'm working with 0 over 1 case. What is 0 over 1? Well, it is 0. And this is the answer. Way 2, maybe you will like it more. Way 2 is to use tricks. Do you like working with trigonometric functions? In this case, you might like this method better than using product rule and chain rule. I noticed that we have sine over cosine case. You don't notice it? Let's look more carefully. I'm working with -5 outside of the limit. As x approaches 0 from the right, the top piece is sine square x. Sine square x is sine x times sine x. The bottom piece is x cosine x. X cosine x. So maybe if I take this piece and combine together in tangent, it will make it better? I don't know. Let's see. So actually, I would even say this way. The result follows right away if you look into those pieces separately. You can still combine into tangent. I think it's actually an extra step. You don't necessarily have to do it. So sine at 0 is 0, cosine at 0 is 1, or tangent at 0 is 0. So the whole piece is 0. The blue part, I will even make it blue. The whole blue box goes to 0, right? Well, sine x over x in yellow, we know this limit. We mentioned it many times. At 0, around 0, sine and x behave the same way. So the ratio gives you 1. That means the whole answer becomes -5 outside times 1 times 0, or basically 0 everywhere. Also, don't forget over here, I think I forgot to mention, we multiplied everything by 0, but actually it's important not to lose -5 in front. What if the answer is not 0 but some kind of number? But still, 0 times anything gave us 0. And this is 2 nice examples for the case 0 times infinity, minus infinity, and so on. The other cases will go to a new video, or else this video will be just too long. I will show you how to deal with the cases infinity minus infinity. This is not 0. Do you know why? Because it's not infinity minus infinity. It's the function that goes to infinity and one more function that goes to infinity. If the first function grows to infinity faster, then everything is infinity. If the second function grows to infinity faster, then everything is minus infinity, right? Because everything becomes very huge but negative. If they grow with the same speed, which is possible as well, then it will be infinity minus infinity and it gives you 0. And you have to justify those cases, and I'll show you a couple examples. And the last 3 are the most interesting ones, so hopefully you will be excited to see those. 0 to 0, what is happening when you have 0 raised to the 0? Anything raised to 0 is 1, but 0 to anything is 0. So what should we expect? Infinity to 0 is interesting as well, and 1 to infinity is not 1 for you to know. You will see what is going on over there. You have to be careful with all those cases. And there's 2 videos coming after this, and you'll become professional when you work with limits that has indeterminate forms. Great job!